Hello, my name is John Mehall, and I am a current online Master of Computer Science student at Rice and a data engineer at Chevron. I work in the Information Risk Management business unit for my company, currently doing a blend of data engineering and data science. The following poster is a project I did for my machine learning course at Rice this summer. So my team deals with all kinds of large-scale big data problems, from managing a data lake solution to dealing with different logs and creating meaningful alerts for real-time reporting. We are responsible for assuring the cybersecurity team can see the full picture of what is going on, meaning we need to get them the most data we can in a meaningful way that will inspire action. One of the sources we have been using is called Virus Total, which is this aggregator of different sources and people report malicious files, and it counts how many malicious reports there were and outcomes. The idea is to use this data to classify if a URL a file is coming from is malicious or not. The goal is to create a model that correctly classifies whether a file is malicious or not. My initial assumption is that this would all be supervised learning, which was a wrong assumption because I ended up doing an unsupervised Keras model, and it expanded my view of what different models can do. Another assumption was that all the data had many variables to choose from. This was initially an assumption because the first data set I worked with was very small and had a small set of variables. My team then purchased a few different data sets, and we had over 50 variables to work with. The last assumption was that this data was labeled with outcomes. So next I want to get into a few of the different models I used. First was a Keras model, which was just over 50% test accuracy, but then I made some tweaks to the layers and the epochs and got it up to 86% accuracy. The next model I used was a decision tree model, which had 96% accuracy on the test data. Then there was a KNN model where I used a plot to determine the most accurate number of Ks to use, and I got that up to 92% accuracy on my test data. And then I used a random forest model, which had only one incorrect false negative classification and a 97.4% test accuracy, which was my best model. So diving deeper into my best model, I dropped from 50 variables that I had to 9, and I dropped the outcome variable. I had 97.4% test accuracy, one missed positive prediction, which is important because when you're predicting malicious files, you don't want to miss malicious ones. I tuned the test size and estimators from 30 to 40 to 20, and then I also played with the test size as well. So thoughts and next steps. This was an enjoyable experience that brought me through the whole data science process. Stakeholder buy-in is key, and I've already met with the team and stakeholders to present my findings. And now I'm working to implement this into current file detection algorithms in my company. Thank you.